Okay, so this video is looking at guiding you through the lessons work on terminal velocity. So by the end of the video we're aiming to have linked our understanding of forces, acceleration and velocity time graphs all together. We've looked at resultant forces, we've looked at acceleration, we've looked at velocity time graphs, but we want to make the link between them so that we understand them. You need to make sure that you've completed all stages of the work. Don't jump any because they build upon one another, and don't be afraid to think about things for a bit and try and puzzle them out before you try and look for an answer or get a bit worked up about it. Just sit and have a think about it and see if you can find the link. On the Google Classroom there is a link to some notes that you also need to have read before you can do this work. You can leave writing the notes up or getting copies of the notes in your book until afterwards, but you will want to read those notes before you start this work. It shouldn't take too long. So the first thing I want you to do, read this description of a journey and try and sketch the velocity time graph that matches it. Okay, you might want to read through this a couple of times and do a section at a time. What the graph should look like is on the next page, so don't skip ahead until you've finished it. You might want to press pause while you're drawing it. So an object starts from rest and begins to accelerate at a constant rate. However, due to air resistance, the acceleration starts to decrease, but the object is still accelerating. Eventually, the acceleration decreases to 0 and the object travels at constant velocity. Suddenly, the object immediately slows down to a much lower velocity. The object then travels at this constant velocity for a period of time and suddenly stops moving. So press the pause button, try and draw that graph before you press play again. So here's a sketch of our graph. We've got a velocity time graph. I've put units in, and you can see that we're starting from rest, and let's see if we can get that a bit better. It's starting from rest. To start with, it accelerates at a constant acceleration. We've got a straight line, so we've got a constant gradient, so we know it's constant in acceleration. And then we say eventually, because air resistance is increasing, the acceleration starts to decrease, but it is still accelerating. So this bit here, you can see the gradient is decreasing, so that's where the acceleration is decreasing, but there is still acceleration. And then eventually the acceleration is 0 and it travels at constant speed. Here, because we've got a horizontal line on our velocity time graph, this is no acceleration, travelling at constant velocity. Suddenly the object slows down dramatically to a much lower velocity. So here you can see the velocity's got much lower. It then travels at a constant velocity for a period of time and then suddenly stops. Okay, so this is what your graph should look like. Right, next job, watch the video about a parachute jump at this link. Okay, you can watch it a couple of times. You might want to keep it there and use it to help you with the next bit of work that you're going to do. Okay, so here's the graph that goes with the parachute jump. Okay, and you can see it matches the description of the journey that we sketched a graph for earlier. So we've got jumping out of the plane, starting to accelerate, speed increasing, air resistance increases, so the resultant force decreases, and we get to terminal velocity here. This part here is terminal velocity. This part here is where we open the parachute. Because it's got a big surface area, the air resistance increases, so we suddenly decrease in speed. And then because we've decreased in speed, our air resistance has decreased, so then air resistance and weight are equal again, so we travel at constant velocity. And then here we hit the ground and suddenly stop. So what you have to do now is use your copy of the graph that you saw on the previous slide and use your storyboard template to draw a storyboard for the entire parachute jump. Each labelled section of the graph needs a labelled section in the storyboard. You can add in extra sections if you want to, so like an illustration of somebody jumping out of a plane and of somebody landing and so on. In each segment of the storyboard you need a labelled free body force diagram. So that's where we've got the centre of mass acting as a dot, and then we've got arrows acting away from the centre of mass. And you need to label the force arrows to say what type of force it is. So is it weight or is it air resistance? Think about the size of the arrows throughout the journey, throughout the parachute jump. For example, is the weight of the parachuter going to change during the jump? Is the size of air resistance going to change during the jump? How are they going to relate to one another? Is one bigger at one point in the jump? Is the other bigger at another point in the jump? And use the YouTube video to help you with this. You need a really brief description of the motion in the little space underneath. So that could be something as simple as constant velocity, constant acceleration, terminal velocity, and this description of the motion you should get from the velocity time graph. And then, and this is one of the most important bits, you need to explain the motion by linking it to the resultant force of the parachuter. So from the force diagrams you can see which direction the resultant force is acting in, so you know which direction the object is going to accelerate in. So you then explain the motion, linking it to the resultant force. Make sure you've labelled terminal velocity and where that's taking place. And make sure that you've read the class notes on the Google Classroom for Newton's first law, Newton's second law, and terminal velocity before you complete this, because it will help. Ask the teacher any questions that you've got, they're there to clarify things, and then bring all of the work completed that was listed on the Google Classroom to hand in for homework.